So very good morning.
Good morning, sir.
So let us have one more time. Very good morning.
Good morning, sir.
Fine. So what today's topic is there, that is a transition state diagram. Okay, so you can note that topic. It's a transition state diagram. So what are the objectives of today's topics are there? The objectives are, so once you complete this one, you will actually know when and how processor executes the instructions. Okay, so the basic objective is, up till now what we have done, suppose we have written the instruction move A comma B. So just we got the meaning. So what are the data is there in B register, that gets transferred, that gets copied in A. But during execution of this one, internally what processor does or how it performs various machine cycles, that information you can get using this a transition state diagram. Okay, so that is the basic objective. So let us have the recapping of certain things. So certain processors pins we have to recall, and certain instructions, two instructions there. Okay, so what is the meaning of reset? Reset. So for the processor, you have one pin that is called a reset in bar. Okay, so this is the active low input pin, right? So when this particular pin gets activated, what happens there? Processor goes in a reset state. Okay, so that means this is actually the physical pin. What the logic is there, that logic is low. Okay, so in order to force the processor in a reset state, I have to generate a logic 0 at a physical pin. Now this 0 can be generated automatically. Okay, that means, for example, if you have the circuit like this one, and if I tap this point, if I call this to be reset in bar, here is the VCC, this is your RC. So the response to power on is this voltage becomes equal to 0. Because for a sudden change, this capacitor is acting as a short circuit. And after some time, this capacitor will charge exponentially. So when it gets completely charged, whatever the logic is here, this logic is nothing but logic 1. And corresponding to that, this pin gets disabled. That means at the instant you switch on this power supply, the processor goes in a reset state. This is called as a power on reset. And another reset is there. That is nothing but your reset key, manual reset. So if you press this reset key, again this voltage becomes equal to 0. As a result, your processor goes in reset state. So the question is, what happens in this reset state? What are the internal status? So immediate effect is, what are the PC contents are there? So PC contents becomes equal to 0, 0, 0, 0. Right? Now what are the internal resistances are there? Different internal resistances, all the general purpose resistances. What are the status is there? That status is arbitrary. They can take any value. Okay, so that is the next effect. Now what are your interrupt system is there? That interrupt system gets disabled. Because if you recall the interrupt structure, that internal flip-flop, RS flip-flop, what you have is, so here you have the R input, and then you have 3 input OR gate. Are you getting this one? And one of the input of the OR gate is nothing but a reset. That is when a reset is generated, corresponding to that, whatever this flip-flop is there, this flip-flop goes in reset condition, and it will disable your interrupt system. So one effect is just to disable the interrupt system. Okay? And corresponding to this reset in bar, one more effect is there, that is nothing but generation of a reset out. When the system gets resetted, you will get a reset out. And this reset out is used to reset external activities. Okay? And whatever the last effect is there, that effect is whatever the buses are there, all the buses goes in tri-state. So one of the important state of 8085, that state is nothing but the reset state. Okay, so when the system gets resetted, you have these effects. Now how to come out of this reset state? If the processor goes in a reset state, how to come out of that? Yes? You have to disable. You have to disable this pin. In this case, automatically it is coming out of the reset. Now manually, if I press this key, and if I hold that pin corresponding to this condition only, the system remains in reset condition. Are you getting this one? That means to begin with, your system must be, that is this particular pin must be disabled. Are you getting this one? So the way to come out of the reset state is nothing but disable the reset input. Okay, so this is the first step which we are calling as reset state. Okay, the first step, let us call this as a reset state. Now another state is, so that depends upon, or that corresponds to your input, that is say a ready input. So we will talk about the next input pin, that is the ready. Okay, so if you have this as a processor, here you have ready. What is the meaning of ready now? It is active high input pin for the processor. That means this pin is generated by external variable. Right? Now since the logic is active high, if this pin is equal to 1, so what the processor is there, processor gets appropriate meaning. And what meaning processor take is, the peripheral is ready for a transfer, ready for a communication. That is corresponding to various machine cycles. For example, if your instruction is of one machine cycle, move A, B. Okay, so whatever the T states are there, T1, T2, T3 and T4. So whatever the activities are there, those activity gets completed within one machine cycle. Are you getting this? So corresponding to T2, for example, what the read bar is there, this read bar gets activated. Okay, so during T2 and T3, your read bar signal gets activated. Right? So if the instruction is of two machine cycles, then corresponding to the next machine cycle, once again, read bar gets activated or write bar gets activated. That depends. So this is the situation if ready signal is equal to 1. Now, but if the ready signal is equal to 0, it indicates that what the peripheral is there, what the memory is there, that memory is not ready. Okay, so instead of going for next T state, now what is this read state is there, that gets extended. It means that the processor is adding the wait states. That means when a ready signal is checked by the processor, it is checked during the T2 step. That will come to that will go for that transition state. In actual diagram, will get when and which signal gets tested. Okay. So if ready is equal to 1, processor performs in normal way, But when ready is equal to 0, it will add wait state. That means further processing gets delayed. It is not stopped. That means that state is not equivalent to the reset state. Only thing is there is a delay. Okay? And what if this delay is there? This delay is used for synchronization purpose. Are you getting explained? That means if peripheral is slow, what happens is this processor will add 1, 2, 3 T states, wait states. That depends upon ready signal. If ready pin is low for say 2 clock periods, what processor will do? It will add 2 wait states. If ready signal is low only for 1 clock period, that means it is adding a 1 wait state. Okay, that means the basic purpose is just to synchronize low operating peripherals with microprocessor. And in this ready state, what happens there? In the wait state, what happens? So whether the register contains any value, whether PC gets equal to 0, 0, 0, 0, no. whatever contents are there prior to that T2 step, the contents remains as it was. The processor is waiting for a ready signal to activate. That is the only thing. What the previous information is there, that previous information gets stored in the registers. Are you getting it? So what is the second state is there? Second state we will call it as the wait state. Right? So during the wait state, processor waits. Activities are not suspended. Processor just wait for some period, 1, 2, 3 clock period, that's all. Now if we go for another signal, so that signal is a hold signal. Okay? And corresponding to that, what are the state we are getting? That state is nothing but the hold state. So again, if you have the processor, suppose this is a processor. So you have a one input pin as HOLD, and the response to this pin is HLDA. Okay, hold acknowledge. Whether it is active high or active low? Active high pin. Okay, hold is active high. Are you getting this one? That means this pin is the input pin which is used by some external controller, some external master. Okay, and the response to this hold pin is HLDA. Okay, so if there is confusion regarding this one, you can put this as HLDA bar. Okay, so whatever the response is there, that response is active high or active low. We'll check this one. But the process is like this one. This pin is used by some another master. Are you getting this one? That means if that processor requires the buses of ADD5, it will raise this pin high. Okay, that means during the normal course, if the logic available here is 0, what processor will do? Processor will continue with its execution. But when this pin becomes equal to 1, now what processor, how processor response is, it will first complete the current machine cycle, not the instruction cycle. So during the T2 state, okay, of any machine cycle, this signal, this pin gets checked. I will repeat. Corresponding to T2 state of all the machine cycles, this particular pin gets checked. If the logic here is 1, then what is the internal flip-flop is there? That internal flip-flop is HLDA, hold acknowledge flip-flop. That flip-flop gets set. Okay? Then again processor come to the next T state. Now the T state is T3. क्योंकि कहाँ पे check किया है वो T2 पे check किया है. So it will come to T3 now. Now after completion of T3, it will again check whether it is the first machine cycle or whether it is the other machine cycles, M2, M3 like that. If it is the first machine cycle, again it will check whether that machine cycle is made up of 4 T states or 6 T states. Because certain machine cycles or 4 phase cycles require 4 T states or 6 T states. So point here is after completion of machine cycle, not the instruction cycle, processor goes in hold state. And in hold state, what are the activities now? In hold state, what are the activities? Just see. Very first thing is, what are the buses are there? Basic purpose is, some another master requires the buses. Okay, that means these buses which are available with the processor must be given to another processor. That means very first effect is, all the buses gets tri-stated, so that those buses can be utilized by another processor. Okay, so that is the first effect. What is the second effect now? What is the previous information is there? That previous information remains there. Okay, and the processor just checks this hold pin. And as soon as hold becomes equal to 0, again it will take the charge of the different buses. Are you getting this? So hold state is again very important. In particularly a DMA transfer, a direct memory access, that DMA controller uses the pins. code and the response from the processor is nothing but HL logically. And very last state is there that depends upon the instruction, and that instruction is the HL. It is nothing but halt. Stop the processing, and corresponding to this, what the state is there, that state is called the halt state. Okay. So HLT, this is the complete format of the instruction. So it is 1 byte instruction. And when this particular instruction gets executed, what happens is processor stops processing. But internally what happens is, corresponding to the first machine cycle, what will happen there? T1 state, PC contents gets outputted. Okay, higher order contents gets placed on A15 to 8. Lower order contents gets placed on AD7 to AD0. And during the T1 only, ALE gets activated. So there is demultiplexing of that bus. During the T2 state, a read bar signal gets generated. Because of that, opcode of HLT is available on database. Right? Now during T3 and T4, that opcode gets decoded. And the decoder's output decide now what is the actual instruction. And the instruction is stop the processing. So corresponding to the T1 of next machine cycle, what is the internal flip-flop is there, which we have to call as halt flip-flop. This halt flip-flop gets set. And when halt flip-flop gets set, processor enters into halt state. इसका मतलब क्या होगा? In order to execute this halt instruction, it takes 5 T states. Okay, not complete second machine cycle, one machine cycle and 1 T states of the next machine cycle. Okay, so what is the effect? Once processor enters in halt state, what is the effect now? Stops processing, buses are not utilized. Now what are the previous contents are there? Previous result was there, say in accumulator or in memory, that result stores. Okay, that means now once we have these 4 states, basic states, so what we have listed here is what is the effect, what internal things happens. At the same time, we have checked the way to come out of that state. Suppose processor is in a reset state, और इसके बाहर मुझे लाना है. So what I will do? Just reset this particular. If the processor is in wait state, okay, so this state is forced by external peripheral. So once external peripheral generate active high ready signal, processor comes out of wait state. This hold state, processor is forced to go in hold state by external device. External some another master. So if this signal becomes 0, disabled, again processor comes out of hold state. Now very important question is how to come out of halt state. If processor is in halt state now, how to come out of that? Okay, so there are various ways. So very first way is you can reset the system. So that's how you do first key that you are pressing from the keyboard is reset. Okay, so the one way is just to reset the system. So what's the topic here? So your important question is how to come out of halt state. So the first solution is you can generate the reset. So manually your reset key is there. So if you press that reset key, processor comes out of halt state. That means the response to this reset is whatever the halt flip-flop is there, this halt flip-flop becomes disabled. Okay, and because of that, the processor comes out of halt state. Another way to take the processor out of halt state is interrupt the system. So very important thing, if processor is in halt state, what is the objective target क्या है मेरा? How to come out of that halt state. So the way is interrupt. But if I want to use this interrupt before halt, you have to write one instruction, very specific instruction. Suppose you have the program, the last instruction is say HL. Okay. Now out of halt state, this is the solution. But to use this interrupt system effectively, what you have to do? Before halt, there should be instruction that is nothing but ER, enable interrupt. Because when you execute ER, then and then only your interrupt system is activated. If this instruction is not there, then interrupt will be, that entire system will be in a disable state. Okay, so what precaution you have to take is, you have to write the instruction ER before halt. Are you getting it? So once again, its effect is like this. What the internal flip-flop is there, that internal halt flip-flop gets resetted. That is the effect of interrupt. Okay. इसके बाद में जो कुछ लिखा है हमने, after halt, see the process now. The sequence comes up to this one. Are you getting the things? Yes. तो यहाँ पे क्या हुआ? Processor acquires halt state. Now to come out of halt state, I am using interrupt. So when I am using the interrupt, means I have to write some ISR routine, interrupt service routine. तो कहाँ पे लिखना है वो? So that depends upon the ISR address and which interrupt you are activating. Suppose I am activating say RST 7.5. So whatever the vector address is there, at that vector address, okay, you have to write your ISR routine. What is the last instruction of that ISR? Return. So when that return gets executed, the processor will take the instruction after halt. Are you getting or not? That means after execution of that interrupt service routine, processor is not acquiring halt state again. Because already we have taken processor out of halt state. That means these two are the ways to take the processor out of halt state permanently. There is one more solution, that is nothing but the hold. Okay, so here whatever state is there, state process हमारा initially halt state है, right? So processor can be taken out of the halt state by using hold. But difference here is this hold. What will do? What is the effect of hold? After completion of the machine cycle, okay, but the HLDA flip-flop is there, that is set, and processor gives the control of the buses to another master. This is the sequence. Now that master will use all the buses. Okay, that means processor is out of halt state. But once that task is over from the another master, again the processor requires halt state itself. इसका मतलब क्या होगा? What is the meaning? Response to hold is not resetting of the halt flip-flop. Temporarily, your processor can be taken out of the halt. Whereas these two are the ways in which you can have a permanent. Okay, that means you can have this flip-flop permanently in a disabled state. Okay. So if we summarize, the thing now, so can anybody summarize? Yes, there are 4 states are there. Can you summarize those states? Yes. Repeat.
First we have transition state diagram. In that first resetting we have seen, the effects by which we can go for resetting are in that first one in all buses will go in tri-state, that effect will occur. Then second one is reset out is generated. And again interrupt gets enabled, all interrupt pins get enabled. Disables, and internal resistance take any arbitrary value. And most important it is all means initially all 000H that will be get
PC contents becomes equal to all
0, 0.
Okay. So that is related with the reset state. What is the next step?
That is ready state. So
wait state.
That is related to ready signal.
Right.
Then the microprocessor is external periphery is accepting means in the state of ready. Then the ready pin will be in active high condition. It means that all peripheral is in ready position, it can accept the normal operation. But when ready signal is 0, then microprocessor have to wait for some time. In that it will generate wait signals, that is wait states. Then third one is hold state. During during T2 cycle, T2 state of the machine cycle, it will get generated, and it is related to the buses. When it is in hold state, external peripheral will use that microprocessor buses. And last one we have seen that the HLT state. For HLT state, how can we come out from HLT state? We have three types we have seen. First two are permanent. In permanent we will go for a reset. Just pressing the reset pin we can come out from the HLT state. And second one again it is permanent, that is instruction. Before instruction we have to HLT we have to write EI, that is enable, and we can proceed for that. And third one is temporary, and that is we can go for hold. So temporary, the buses of the microprocessor are used by external peripheral, and we can stop the microprocessor actions.
Okay, that means the permanent way is just to use reset and interrupt. The temporary way is just to use the okay. Now whatever the activities are there, these activities we have to represent now. Okay, using a diagram. That diagram is called a transition state diagram. Okay, so things are a little bit complicated, but whatever the internal process is there, that internal process gets reflected once you just check the things properly. Okay, so once again, as far as the weightage is there, you have the question for 10 to 12 marks. Okay, if the question is there, it is for 10 to 12 marks.